Hi, my name is Franklin Noble, and I go to the School for the Talented and Gifted in Dallas, Texas.
And my name is Nihal Pothunoori, and I go to school at Maggie Walker in Richmond, Virginia.
We had a lot of ideas for our instrument, but none of them felt befitting of an orchestra. None of them felt like something a conductor would be willing to conduct. But then we realized that maybe conductors didn't need more instruments in an orchestra to produce music. Maybe, with a little bit of wiring, they could conduct themselves. For our project, we harnessed the electrical potential of the human body to create the world's first orchestraless conductor.
Okay, so here's a quick demo of our project. When I flex my bicep, I will actually be playing a note from the speaker, and I can control the pitch of that note with this ultrasonic sensor right here. So I'm going to flex my bicep, and I can control the pitch of that note using the ultrasonic sensor. And I am going to also be able to control the octave using this baton right here. So I'm going to flex my bicep one more time. And I'm going to be able to control the octave of that note with the up button, and I can bring it back down to its original pitch using the down button. All right, that's our project. So in the demo that you just saw, our project has three parts: an operational amplifier, an ultrasonic sensor, and a baton. And I want to talk about the operational amplifier first. When we flex our muscles, our brain will output a little electrical signal to the muscle saying that it should flex. And so we actually use an operational amplifier to amplify that really small signal, which is in millivolts, and we amplify it to a voltage that we can read, and that's what we are outputting on the Arduino screen right now. So what we've done is if my bicep is flexed, the buzzer will play the note. If my bicep is not flexed, the buzzer will not play a note. Then the second part of our project is the ultrasonic sensor. That actually will map out the distance in centimeters, and we map that to the pitch that the buzzer will play, which will be between 0 and 3,000 hertz. But what if I want to play a song, or if I want to play a note that has frequencies that are more than 3,000 hertz? Well, what I can do is I can increase the octave by doubling the pitch, or I can decrease the octave by halving the frequency of the note. So that's what we use a baton for. There's two buttons on there.
The biggest challenge we had was actually building the operational amplifier. We weren't able to use a pre-made amplifier, and most of the schematics for op-amps we found required 5 transistors. Finding a suitable op-amp schematic, and then actually modifying it to work with the specific transistors we had, was really difficult. When we finally did get it to read the millivolt signals our bicep outputs, we were only able to identify whether the bicep was flexed or not.
Actually, our original idea was to use a bicep to determine pitch. So the pitches would correspond to how much our bicep was flexed. That was our original idea. But then when we realized we could only measure two states of the bicep, either flexed or unflexed, we actually changed our plan, and we made it so that the bicep would control if the buzzer was on or off, and then we instead used the ultrasonic sensor to control the pitch of the buzzer.